In example 1, consider a situation where we have a crate that is existing on an inclined plane. Now we are applying a force of 100 newtons onto the crate, and our crate has a weight of 300 newtons. Now our plane is inclined 30 degrees above our horizontal axis. If we take our coefficient of static friction to be 0.25 and our coefficient of kinetic friction to be 0.20, we want to determine if our crate is in equilibrium, and we want to find the value of our frictional force. For us to begin, we'll construct a free body diagram, and we'll also rotate our axes 30 degrees. Now, we're going to apply our equilibrium equation in the x direction. The summation of forces in the x direction has to be equal to 0 for equilibrium. Looking at our system, we have our applied load P plus our frictional force has to be equal to the weight of the crate in the x direction. Or our frictional force is the quantity 300 times the cosine 60 minus 100 newtons. Or our frictional force for this crate to be in equilibrium is 50 newtons. Now, if we apply our equilibrium equation in the y direction, we'd have the summation of forces in our y direction being equal to 0 for static equilibrium, and we see our normal force has to be equal to the weight of our crate in the y direction. Or our normal force is 300 times sine 60 newtons, which is 260 newtons. Lastly, we can determine the magnitude of our maximum frictional force. And F max is equal to our coefficient of static friction times the normal force, or 0.25 times 260 newtons, and our maximum frictional force is 65 newtons. Thus, since the value of our force required to maintain equilibrium, i.e. our frictional force is equal to 50 newtons, is less than that generated by our coefficient of static friction, 65 newtons, motion is not going to occur.